that we can help clear the hallways and get all students to their appropriate classrooms. Again, all students should be inside their classrooms at this time. Teachers, please mark latenesses and calls accordingly. We appreciate it. Everyone have a wonderful weekend.
That means you selected my homework. Like,
That many times?
Oh, we can't see.
Okay.
yeah,
All right.
That's a
27.
you left my homework today.
Well, you'll see what the dice decide, Bethlehem.
Oh,
So we got y equals x, y equals 2 minus x, and y equals 0. And we want to find the region bounded by these three graphs. Is that correct? For 27? All right. And 20. All right, we'll also get 20 up here. Thank you.
29?
Because I misspoke.
Like right now?
Yeah, I was wrong. Not 29. I said the wrong thing.
Right now.
Yes, not 29. 27. So, 27. The graph is helpful. So you got y equals x, 0, 0, 1, 1, whee. And you got y equals 2 minus x, 0, comma 2, 1, comma 1 again, 2, comma 0, woo. And then you got y equals 0. That's just the x-axis. So we're finding this area here, this little triangle. Now, there's two ways to go about finding this area. What's the easy way?
The shape John. 1/2 base times height.
Why, some base times height. You say that's a triangle.
I did not say that.
Oh, no.
1/2 base times height.
Wow.
Base looks like it's 2.
That's crazy.
Height looks like it's 1.
How do you think about it?
Area is 1.
Wow.
Done. So that's the easy way. Now, if you insist on doing things the hard way, that's fine.
Everyone
didn't know that was
insists
enough.
on that.
Yeah,
Sorry, there you go. If you want to do things, so guys, here's the graph. Y equals x is up here. Y equals 2 minus x is down here. And you see this region. Hey, look, triangle. We love triangles. They're so easy. Find the area of a triangle. 1/2 base times height, right out of geometry. Boom, area is 1. But if you want to do things with an integral, it's like, no, damn it, this is integration. I'm going to do integrals. Okay, fine. Good luck to you. It's more complicated that way. And what makes this one especially complicated is who's on top. It depends, yeah. So who's on top between 0 and 1?
No.
Nope.
Y equals X.
Y equals x. So not on top of the whole thing, but on top of the region. So we care about this region enclosed by these three lines. This y equals x, 2 minus x, and the x-axis. So on top of the enclosed region is y equals x. So from 0 to 1, the top curve is x. Who's the bottom curve on this region?
The other one.
0.
Oh.
Then for the second interval from 1 to 2, now who's on top of the enclosed region?
The 2 minus x. Right.
2 minus x. And who's on the bottom here? Still 0. So that would be your setup with the integral. You would have to break this into two separate integrals. One from 0 to 1, when y equals x is on top of the region, and 0 is on the bottom. And then a second integral from 1 to 2, where 2 minus x is on top of the interval, or of the region, and 0 is, again, on the bottom. So then you'd have integral from 0 to 1 of x dx, and then another integral from 1 to 2 of 2 minus x dx. And then once you got that, doing the integrals themselves is not difficult, but setting up the correct integrals, if this is the way you want to go, is the difficult part. But if you see an easy way to go, like if you see, hey, that thing looks suspiciously like a triangle, do things the easy way. Boom. Use your area formula for a triangle. There's nothing wrong with doing that. You are definitely allowed to use geometry or basic algebra skills when they are applicable. Yes, Noel?
You just call them lines.
Yeah.
Is there another term for it?
Curves?
So we're ever going to have one
Mm-hmm.
like
Yeah, probably.
that we never or is that
Well, I mean, this is 3 curves.
oh, you're right.
So there'll be times where you have 4 curves, but like the first curve and the fourth curve are like a vertical line and a vertical line setting off the bounds, or a horizontal line and a horizontal line setting things off. So often you have 4 curves, but 2 of them are kind of just blocking things off, and then it's the region between the 2 other equations. Sam?
So if they didn't give us like y equals 0 or anything, we do not know what region to find at all.
If they wanted us to find this particular region, they need to give us y equals 0, or they need to say between these curves and the x-axis, or enclosed between these 2 curves and the x-axis. So yeah, if they want to be like really precise, they'll give us that extra equation just so there's no room for like misunderstanding. Or as little room for misunderstanding as possible. Because if you take this away and you say between the curves, like, well, between the curves is like here and here, and then like where do you stop and where do you begin? And you just have one intersection point. There's no second intersection point for us to like have another to like enclose the space. There's no really enclosed space. So they have to give us a third thing to say, okay, well, let's enclose some space. Oh, we'll enclose this space right here. And we'll do that by saying the x-axis is another line.
So if they said like the bounds were 0 to 2,
Yeah.
would we know that it has to be between the x-axis, or could we assume that it's the triangle between the y-axis and the
You have to be careful how it's worded. If it's, so this one, it's sketch the region bounded by the graphs of the algebraic function. So the region bounded by the curves are, well, here's a curve, and here's a curve. The region bounded by these 3 curves is this triangle down here. If they say the area between the curves, if we want to go in between the curves, that means above one curve and below the other. And then they have to give us like x equals 0 and x equals 2, and we would be finding these 2 triangle areas. You know what I'm saying? So if we say, so here it was region bounded by the graphs or by the curves of ... And so with these 3 graphs, with these 3 lines, the area bounded is this guy right here. If we go find the area between the curves, and then we have to take this out, y equals x and y equals 2 minus x. We'd have y equals x, we have y equals 2 minus x, and then area between is this space and this space. So then we would be forced into, they would have to tell us a beginning and an end. So they might say x equals 0, and say x equals 4. And then area between is, that's between the 2 lines, that's between the 2 lines, and then 0 and 4 for x give us a beginning and an end. So wording matters, which is kind of tough. Anything else with this? All right, and then we had a request for 20. 20, similar sort of idea. It was another, find the area of the region bounded by the graphs. And for 20, it was y equals negative x squared plus 3. X cubed, thank you. Y equals x. X equals negative 1 and positive 1. So, x equals negative 1. I don't want to go that far. So x equals negative 1. X equals positive 1. Y equals x. This is 1, 1. Negative 1. So then I'm going to be down here. Negative 1. This is my line y equals x, right? And then y equals negative x cubed plus 3. So plus 3 is up here. then negative x cubed is going to be one of these things. And if I go to 1, negative 1 cubed plus 3 is positive 2, right?
Oh.
Right? So this would probably be a 4. So this up here is y equals negative x cubed plus 3. So at negative 1 cubed is negative 1, negative 1 is positive 1, 1 plus 3 is 4. So we got negative 1 comma 4, and then positive 1 comma 2 for the cubic function.
Did you change the assignment in between Wednesday and Thursday?
I took off 2 problems, I think. Did I take off 20?
You added 2.
No, I took off.
Yeah, I have less time. Yeah, no, you added 20 and 23.
I thought I took off 20.
I did.
Oh!
I did 20.
I took off them from Wednesday, but I forgot to take them off
Yeah.
from Thursday.
Oh.
I'm sorry.
Right.
I
So
forgot to
I
take
did
them off from
20
both places.
23. I did
So if you looked at Wednesday's assignment, there was no 20 and 23. And if you looked at the version of Thursday, then you, okay. I apologize.
Why you shouldn't collect over.
No, I think you should still collect it.
Just don't
Give
give
everyone
everyone
a point.
Alright.
Still give
I
them
will,
credit.
if you didn't do 20 and 23, fine. I didn't intend for you to do them. I just forgot to take them off. If you did 20 and 23, I'm sorry for having you do more than what I intended.
I mean, they
So, area, anyway, so the enclosed space is all this stuff right here, right? So, integral is going to be, what are your bounds? Negative 1 to 1. Who's on top? Cubic guy. Who's on the bottom? Yeah. So, this guy's top. This guy's bottom. Top minus bottom. And there's no like terms, and you don't even need to distribute a negative because the bottom term is just one piece. So then you can just go to town on this and say that's negative 1/4 x to the 4th plus 3x minus a half x squared. And we're going from negative 1 to 1. Any questions with the graph or the setup of the integral? You evaluate this, you got negative 1/4 plus 3 minus a half, and then you subtract, plug a negative 1, and this is still negative 1/4, minus 3, and minus a half. So, what's negative 1/4 minus negative 1/4? 0. What's negative a half minus negative a half? So we end up with 3 minus negative 3, which is just 6. Because these guys cancel and these guys cancel. Cool. It's fun to me. I don't know. My idea of fun has probably worked. It's fun to me that this shape would have an area that's so nice. It's like a whole number.
Yeah, I was not expecting
But it's not a trapezoid because this is curvy. So the fact that this turns out to still be a nice whole number is a little bit of a nice surprise. All right. Dice. Is there anything else we need to look at besides 20 and 27?
Can you roll the dice 2 times? Can you flip them? Can you like perform like a coin?
Like this?
Yeah!
That's a 2.
Yeah! No! Roll it again if I know 3, please, I'm begging you.
2.
Yeah! Oh my god, please roll it again. I like this method. Please.
Okay. Sorry, this one dropped here between the.
Roll it again.
I can throw it at Javier.
What are you doing?
Roll it again.
Yeah,
Please.
throw it at
No,
Javier.
That's
it's
another
2
2.
again. It's
No,
2 again.
come on.
It's 2 again.
Come on.
What are you?
3. Oh my god.
That was fun. 4.
Oh, can you roll the other one again? So there's 3
This is
rolls.
all your fault.
It don't work like that.
This is all your fault.
Why are you starting
Still
over?
a 2.
Oh my god, one more time. One more time.
One more time. I
It don't
rolled
work
that.
like
Rolled
that.
twice.
One more
Like
time.
6 times.
It don't work.
3 rolls. I don't know. And I have it.
Yeah.
You roll.
I'm starting to
You want to roll?
Can I
You
just
roll it
grab
one
it
more
every
time.
3
You
times?
roll it. No.
No.
Legit roll.
No.
didn't roll a 3. She wants a 3.
Wait,
Lily,
you
there's
rolled
no
a 3.
free drink.
Okay.
Can I roll it? Drink.
Alright.
Center.
I got a 5.
Okay.
Alright,
This is
it's not like
literally-
let's just watch.
Ready?
January.
All right, well,
We missed your
happy
birthday.
belated birthday for me.
You missed your
No, I'm
birthday.
Aw,
Bro,
thank
when's
you.
your birthday?
That's supposed to be a bow tie.
This birthday, you're not gonna open it?
Yes. I mean, unless you like hit Olivia with it in the
I
head.
don't know. I don't know.
You're not gonna open your gift?
What a nice cat.
I thought I would save
We
it
just
for later.
collect 3 without the dice.
Oh.
What is that?
It's dice to tell you.
I wrapped it nicely.
Please.
Javier, can I pick it?
Okay, I'm not.
Yeah, don't think.
Read it, read it. What's it say?
Besties, Olivia and Javier. I thought that's what it said, but I wasn't sure. The writing wasn't the best. I love these things. Thank you.
We gave that to you to flip the case.
Oh, really?
I'll take it.
Mr. Gregory,
You actually
like
like
to the back of your room.
Well, if they're still there at the end of class, I will take them, and that'll be my snack.
You actually like
Give them to your kids.
I gotta get from like breakfast at 6:30 in the morning till lunch at 2 o'clock. I need a snack.
you like that too?
Well,
That's so sad. I'm so sorry.
Yeah, I have my one block board.
Oh, you're a victim. Sorry.
Yeah, I can manage.
Why don't we just keep her in class?
Hey,
This is not really. I'm sorry. This is not whiteboard friendly. It's too much. It's really not. It's really not. All right. So what I'm giving you right now is Monday night's homework.
Oh, what, the random dude?
Yeah.
Yeah, I have no idea.
Oh, tall guy from yesterday?
You should
Oh,
collect
I
my
don't
homework
understand.
as an apology for forgetting.
Oh, okay. No, the guy yesterday was like taller than me.
He keeps walking past the door. I like open the door.
Yeah, that's what happened with me.
Okay, that's fine.
Mr.
You not
Edgar, you
get
should collect my
I
homework
will.
as an apology for forgetting me so many times.
This is why they make
And when will you collect my homework?
1,
I've
2,
collected it in so many
3.
times.
I've collected you 3 times this quarter. What was it? 2 and 4?
How many times have you collected homework?
More than that?
Way more than that. Way more than that.
I'm glad you're happy, Sam. Your happiness is my goal in life.
So are you making me?
Considering I barely got
I
past the last
don't,
semester,
every time you do that.
Mr. Edgar,
Yes, ma'am.
can you start saying slay in the middle of your
Slight?
lesson? Slay.
Slay? Like Slay Queen?
Yeah.
Slay Queen.
Don't listen to anything. No, please don't.
All right, people at home, I'm sorry for the chaotic mess that our class has become. So, your homework tonight is 31, 32, 33, 35, 40, 47, and 81. What's 81?
81.
81.
54.
Ooh, let's talk about 81.
81, what's 80? For what? On what?
So I'm gonna project 81 up here on the board.
Oh, it's not on the worksheet you gave us?
No.
So with-
So the worksheet I gave you is Monday night's homework. So you have homework in tonight's folder on Schoology, and that's due Monday.
Oh,
And then you got this worksheet, which is the homework that's due on Tuesday. So you have them both now. You can work on them over the weekend. And I'm thinking it's probably better for us to look at 81 together than to start picking on some of these problems.
81 where?
81 is from tonight's homework. So I'm putting it up here. I gotta adjust the,
Why don't you just give this stuff on Monday when everyone's here?
I'll give it to them on Monday.
I'm not complaining that I get a head
Okay.
Why, yeah.
No,
All right, so 81.
Mr. Edgar,
Yes, ma'am.
can I roll the dice on Monday?
Sure.
Just to make sure.
What difference?
It makes a large difference.
If it makes a difference to her,
He's bringing it. Maybe they're waiting. Have you ever thought that maybe your dice are weighted?
Honestly, yeah.
I've had people accuse me of that before.
They are. I mean,
One time when I was like
I'm not
11 and my little brother was 8 and we were playing a board game together, he like got really angry and started physically attacking me and accusing me of loading the dice because the dice. No, this is the little brother, yeah. So little Edgar, not the one who works here.
not here.
Not here. No, he's
How
not
many
crazy.
Edgars are there?
There's a lot of Edgars.
How many?
You'll have to.
There's 5 of us. I've had 4 siblings.
Okay.
What?
There's not twins.
No, there's no twins.
Oh, that'd be great.
My sister has twins, so there's that doesn't count. They're not Edgars. They're Perkinses.
Which one's your favorite?
Do what?
I'll answer that.
Which favorite?
All right. So you got 2 cars on a straight track with velocities v1 and v2, and we're going to measure this in meters per second. And then we have 3 different integrals that were being given. So first integral is from 0 to 5, and that's v1 minus v2, and we're told, hey, that's 10. And then we have a second integral from 0 to 10, and that's v1 minus v2 again, and that's 30. And then the third integral you can see there. So in part A, we want to say, well, basically interpret each of these integrals. So before we do that, just think of like, what if we just did the integral of v1 on its own? And say we did that from 0 to 10, and I'll just make up a number, maybe that's 20. So if we have a car and it's driving along some track, and this is the integral of its velocity, what does this mean? It's been a while since we talked about this. This is going back, way back to chapter 4. So this is velocity. So what's the integral of velocity tell us about this car?
The
Position.
No, that's the derivative.
Position.
So position, but this isn't the position at a particular time. This is the position over a period of time. And so it's not like, we got to tell me more about the position.
So it's at 20 from
start and the
0
end.
seconds.
Start at the end, yeah. So at time 0 to time 10, how far does the car move? So we could say car
From 0 to 10 seconds.
is 20 meters away from where it started. So at time 10, at t equals 10, the car is 20 meters away from where it started at t equals 0. So this is almost saying it travels 20 meters. But we don't want to go that far, because it could be that the velocity is positive and then also negative, and then maybe positive again. And that isn't captured unless we put absolute value. Without the absolute value, we can't say that this is the distance traveled, but we do know from the beginning to the end, it's 20 meters away from where it began. All right? So if we now come back to the problem in 81, where we now have 2 cars and we're subtracting the velocities, what is that telling us now? So we just talked about with a single car, that's basically how far it moves from the beginning to the end.
The distance between both the cars is 10 meters.
Yes, so the distance the 2 cars move is a 10-meter difference between them, beginning and end. And here, from 0 to 10, same idea. What would we say here?
The distance between car 1 and car 2 over the time, or over 10 seconds.
Very good. So car 1 travels, or is 30 meters away, is 30 more meters away from where it started than car 2. For this one, where you have a negative result for the integral, what does that mean? They passed each other. What else? They didn't move backwards necessarily. Yeah.
I said that.
Now car 2, yeah. Olivia, the besties. So Javier and Olivia. Yay. Now car 2 is further along than car 1. So between second 20